Welcome back. Note that in the addition algorithm, we successively add a pair of bits and possibly a carry amount. That is, there are at most two additions for each column of addition. Okay, so I hope it's clear. When you have a carry, you add that. That's one addition, and that's one more addition. So there are at most two additions for each column of addition. Thus, the total number of additions of bits used is less than twice the number of bits in the expansion. Hence, the number of addition of bits used by algorithm to add two n-bit integers is order of n. You see, the length is n. You have twice n at most number of additions you go through. So the order here, so the number of additions is order of n. Okay, so you might want to come up with an algorithm for subtraction in the same fashion. Subtraction, think about it and discuss. All right, now how do you multiply two integers given in binary expansion? So let's go through this. You multiply these two integers in binary expansion. So 1 times anything is itself. 0 times anything is 0. Notice I have one more 0 because this takes the position of 2 to the power 1. So 0 is in the middle position. There is one empty spot in the right, and that's a 0. This one, when I multiply, I get the same. But notice that one is followed by two zeros. So I have two zeros here. Now adding. You have already seen addition of numbers in binary description. So you go ahead and add. That's how you multiply. Okay. So let's look for a pseudocode. You have a and b, two positive integers, binary expansion given accordingly. So you go from right to left of b. So this is the second number. You start multiplying with b naught, then multiply by b1 and so on. If bj is 1, then cj is a shifted j places, you see. So if whenever you have 1, you have the same number written down, but there is a shift if this has two spots here. Okay, so if you have any spots, those many places you shift. If bj is 0, you have 0. All right, so these are your partial products. Start with the final product to be 0. Now you are just incrementing p, so you are adding p and updating it by adding it to cj systematically. So p is the value of the product. That's all. Now let's look for multiplication algorithm. How many number of additions and bits? So certain number of additions of bits and shifts. Since b is a string of length n, we have 0 or 1 or 2 or 3 or n minus 1 shifts. So adding all of them, that's n times n minus 1 over 2 number of shifts. So notice this is n times n. So this is a polynomial of degree 2. So order n squared. Now you are adding n bit integer as an n plus 1 bit integer all the way until 2n bit integer. So these are all at most length 2n. Each integer is each ci is at most length 2n, and we have already seen when adding integers you are basically looking at order n. So in all, order n squared and order n gets you order n squared number of shifts and so on. So that's the amount of operations you need. Next, division. What is division? Division is a series of subtractions. Moreover, remember when your dividend is less than 0, divisor is greater than 0, then the quotient is slightly different. So let's understand this bit. Division. What's the meaning of 35 divided by 8? Divided by 4? Quotient is 8, remainder is 3. Now, how is division repeated subtractions? Well, 35 minus 4 is 31. That is one subtraction. 31 minus 4 is 27. That's my second subtraction. 27 minus 4 is 23. Third subtraction. 23 minus 4 is 19. Fourth subtraction. 19 minus 4 is 15. Fifth subtraction. 15 minus 4 is 11. That is my sixth subtraction. 11 minus 4 is 7. That's my seventh subtraction. 7 minus 4 is 3. That's my eighth subtraction. And we stop because that's smaller than 4. So there were 8 subtractions and 3 is the remainder. So quotient is 8, remainder is 3. Now what happens when you are dividing negative 30? So this you understand. But what happens when your dividend is negative? Say negative 35. If you are dividing by 4, quotient you would say is negative 8 and remainder is negative 3. But this does not work because remainder should be a non-negative number. It cannot be negative. So you go one more to the left. So 4 times negative 9 is negative 36. Negative 36 plus 1 is negative 35. So negative 35 is 4 times negative 9 plus 1. Now that is an acceptable remainder. So when you are dividing a negative number, remember you don't stay the way you are when you divide by divide a positive dividend. So quotient was 8. When you divide a negative number, quotient is a farther more to the left. So instead of negative 8, you would go negative 9, a little more to the left, thereby getting a positive or rather non-negative remainder. Okay. So in general, for a divisor, a dividend which is positive, you know how the division algorithm works. A equals QD plus R. D is your divisor, Q is your quotient, R is your remainder. But when I take negative A, I get negative QD minus R, which is not okay. So I go a little more to the left. That is, I take negative of Q plus 1D. So you see that means I have essentially a negative D. So I add D. D minus R now is non-negative. It is still smaller than D. All right. So that's how division algorithm works. D minus R is the new remainder. All right. Computing algorithm, procedure division algorithm. A is an integer, D is a positive integer. Start with quotient equals 0 and remainder equals absolute value A. Remember, your remainder is supposed to be smaller than absolute value A. So to begin with, that's my remainder. Smaller than, right. While my remainder is greater or equal divisor, so as long as I have a remainder which is bigger equals divisor, I reduce. So remember, division is repeated subtractions. I reduce my remainder by D. Every time I subtract, I have to add my quotient. If my A is less than 0, R is greater than 0, then go once more. All right. And Q and R are the respective quotients and remainder. This requires n squared bit operations. Okay. What is n? N is the length of your binary digit description. Okay, you can think about it because you are subtracting, you see. So there are you'll have to argue this. Okay, it's an n squared, order of n squared operations. Maybe more detail will be needed, but you can argue it out. All right, let's continue in our next video.